Okay, this is example 1. So here's the given non-homogeneous differential equation, right? Notice it's not equal to 0. So this guy is going to be my f of x, right? This is my function of x. And this is the goal. The goal is to find y. This is the general, again, solution to the non-homogeneous or non-homogeneous equation opposed to the homogeneous equation. So we're going to find our y sub c, or y complementary function, plus our y particular function. Now this part is, this is the new part right here in 2.5. This is where we construct this particular solution to this differential equation. The y sub c, we already did this part, right? This was again in section 2.3. So in your book, on some of your homework problems, it might say, like for example, 1 through 20, it says find a particular solution of the given differential equation. It doesn't necessarily ask you to find, in that specific problem, it doesn't ask you to find the y sub c. I'm going to go ahead and do the y sub c because it's a great review anyway for eventually, we're going to do this, and it's a great review for the test. The yellow part is really just, again, 2.3 using the characteristic equation. Okay, so step 1, right? So step 1, right, from the first video was to find y sub c. So find y sub c, right? And this is again from section 2.3. So let's write our homogeneous, here it's the second order differential equation. So we have, okay, so we have y double prime minus 3y prime minus 4y, right? So we're going to set that equal to 0. And our characteristic equation, right, this is, well, our root is going to be y prime. So this is going to be r squared minus 3r minus 4 equals 0. Again, we're using our characteristic equation, right? Which is associated to this differential equation above. And then again, this is all based on, this is just algebra 2. We're just factoring really to find our y sub c. There's no greatest common factor, but we can unfoil, right? We can say r times r is r squared, and this is going to be 1 minus plus, right? Negative 4 times 1 is negative 4. Negative 4 plus 1 is negative 3. So we have r is equal to 4, or r is equal to negative 1, right? Remember, we call this maybe r1 and r2, or the other way around. Okay, so what is our y sub c? This is our general solution to the homogeneous equation, not the same thing as our y. So, well, we know that's just c1, right? E to the r1x, so in this case to the 4x, plus our constant c2, and it's e to the r2x, so in this case negative 1 times x, which is negative x. So I'm going to go ahead and just, box this in yellow. All right, there's our y sub c. Okay, so, check. We already found that. Now let's move on to our y sub p, and then we just add it to our y sub c, and then we get our y sub, our just y. So let's see, let me make this a little bit smaller. Okay, so step 2 is we want to try to guess a particular solution, right, to this non-homogeneous linear equation. So by constructing a particular solution. So let's just go ahead and write that down. So let's construct a y sub p. Okay, so what is my y sub p? What am I going to call it? Well, you want it to look very similar, right? Have the same form as, let's maybe get a different color. Let's get maybe, okay, this blue or purple, hopefully you guys can see that. So you want it to be very similar, right, or the similar form or similar type as your f of x. So notice it's an exponential function, right, 3 times e to the 2x. So we want to call that, I want to construct it, and I want to say a, where a is some constant, times e to the 2x, right, because it was 3 e to the 2x, so instead of 3, write some general constant. And then from here, you start taking, you'll notice we're going to use the derivative and the second derivative. So if we take the derivative of y sub p, right, we just get 2, right, using the chain rule, we get 2a e to the 2x. And if we take the derivative again, we get 4a e to the 2x. Okay, so now we're going to, let's go ahead and write, we're going to, we're going to substitute y sub p prime, and y sub p double prime back, right, into our original, into our non-homogeneous equation that we have above. So maybe call it star. So it's just our original equation. So it's going to be, right, this guy. Okay, so let's go ahead and substitute our y sub p's back into our star equation, our original equation. So I'm going to go ahead and just write the original equation. Y double prime minus 3y prime minus 4y equals 3e to the 2x, right? This is, again, our f of x. And we have, so y double prime is right here. We have 4a e to the 2x, right? We're literally just substituting. Minus 3 times, okay, what's our y prime? Right here. And so I have 2ae, and that should be a 2x, which I just forgot to, oh, it is up there. Okay, but it includes that 2x. And then, of course, y sub p is our, what we constructed, ae to the 2x. So we have minus 4, and then our y is ae to the 2x, and that's an ugly 2x. So let me make it look a little bit nicer. And then equals, and of course our, let me make this a little smaller, so we have 3e to the 2x. Okay, so constructed my y sub p, found y sub p prime, y double prime, and I substituted my values. We can make this look a little bit nicer, right? Simplifying a little. So this comes out. This is just 6ae to the 2x minus 4ae to the 2x equals 3e to the 2x. Okay, so on the left-hand side, notice we have some like terms here. So we have e to the 2x, e to the 2x, and e to the 2x. So, I mean, this is really 4a minus 6a minus 4a e to the 2x, or, I mean, if you want to think of factoring e to the 2x, that's really your greatest common factor. So that's all I did, 2x. And, right, 4a minus a, this is nice, and then we're left with negative 6a e to the 2x equals 3e to the 2x. And what we want to do here is we want to equate the coefficients. So notice that we have, okay, our function, right, is we're working with e to the 2x, and this is e to the 2x. Well, if we're setting this expression equal to this expression, right, and we know these guys are the same, then I'm allowed to set these coefficients equal to each other. So that implies negative 6a equals 3, right? And then, of course, solving for a, we just get negative 1/2. So, I mean, that's one way of looking at it. If you want to think about it So again, options, e to the 2x equals 3e to the 2x. Another way of thinking about it is we know that, let me write it right here. We know that, right, the function e to the 2x, right, looks, you know, something like this, right? Remember, there's a horizontal asymptote right here. So this, okay, this is not the best graph, right, but it starts very slow and then it just kind of explodes. But this graph is it's going to get very, very close to our y-axis, but it's never actually going to touch the x-axis. So we know that this is never going to be 0. So since we know it's never going to be 0, we're allowed to divide by this function. And then, of course, I mean, that's just a big 1, that's just a big 1, and then notice you get the same, right? We get the same equation. So that's another way of thinking about it. But we got our a, which is -1/2. So now, whoops, now we can write our y sub p, right, or y sub p of x. Well, what did we call our y sub p of x? It was, I think, a e to the 2x, right? Remember, it was a e to the 2x. And, well, we found our a. Our a is -1/2 e to the 2x. So y sub p of x is equal to this guy. So now, right, final step. Okay, so now, no e, we can write, okay, the general solution, okay, to our non-homogeneous equation. Again, not the general solution to the homogeneous or homogeneous equation that we did in 2.3. So our final solution, right? So we have y equals y sub c plus, right, our complementary solution plus y sub p, a particular one. And we have y equals, and then our y sub c from our characteristic equation was c1 e to the 4x plus c2 e to the -x. All right, if you want to put parentheses or not, plus our y sub p, which is, well, we can write plus, but we know it's going to be minus, or plus, it's the same thing. -1/2 e to the 2x, right? So that we found our y sub c, and our y sub p. So this is the final answer, right? This is the most general we can get. Notice that we don't know what our C1 and our C2 is, and that's because this differential equation doesn't give us initial conditions. If it did give us initial conditions, then we could determine C1 and C2, which we'll probably do a little bit later, but again, this is the first example. So again, this is the idea, right? 3 steps. So I will stop here and I'll do another example in example 2.